Our next topic for the AS level chemistry is the hydrocarbons. Hydrocarbons are the compounds of carbon and hydrogen. Basically, these are the organic compounds. The main source of hydrocarbons are crude oil, coal, and natural gas. We know that crude oil is a mixture of hydrocarbon. So, using the fractional distillation, crude oil is further split up into the different fractions depending upon their boiling points. Now, from crude oil, with the help of fractional distillation, we get variety type of hydrocarbon. These are called as parent hydrocarbon. These hydrocarbons are of two types basically. The first is called open chain hydrocarbon and the second type is called as closed chain or cyclic hydrocarbon. Closed chain or cyclic hydrocarbon. These are the parent hydrocarbon and these are the saturated hydrocarbon. Saturated means all the valencies of carbon are satisfied with the help of a single covalent bond. All the valencies are satisfied and such type of the compounds which contain only single covalent bond between carbon-carbon atoms, those are called as saturated hydrocarbons. Now, the open chain hydrocarbon have general formula CnH2n+2. But the cyclic compounds follow the general formula of alkenes because the first and last carbon atom join together with the removal of two hydrogen atoms from the alkenes. As the nature of the hydrocarbon concerned, these are basically non-polar compounds. Hydrocarbons are the non-polar compounds. So, according to the formula, like dissolved like, mean organic compound will be dissolved in organic, inorganic will be dissolved in inorganic, polar will be dissolved in polar and non-polar will be dissolved in non-polar. For example, if we take any hydrocarbon, say oil or petrol, and as these are non-polar, and if we put water into the hydrocarbon, what will happen? Due to the lesser density, water will float on oil. This will remain two immiscible liquids. Why? Because water is a polar, inorganic, while oil is a non-polar, organic molecules. That's why all of these will remain insoluble depending upon the difference of their density. They will change their respective position. Similarly, if we take oil and if we put into it a fats will not be soluble in water, but fats can easily be soluble in oil. Fats are organic, oils are also organic. Both of these will dissolve immediately and that formula will be explained that like dissolve like. Now, as concerned the reaction of hydrocarbons, reactions of alkanes, two types of alkanes reactions are there. Reactions of alkanes. Two types of reactions are there. Number one, combustion, and second, free radical substitution reactions. Substitution reactions. Now, if we discuss the combustion reactions, all hydrocarbon on complete combustion in oxygen. For example, if we have butane C4H10, if we burn this in oxygen, all hydrocarbon on complete combustion produce carbon dioxide and water. Now these equations can easily be balanced on the basis of the number of carbon atom and oxygen atom present on reactant on product side. Here carbon is 4. Definitely the 4 mole of carbon dioxide will be produced. Similarly, 10 hydrogen is there. If we balance it, then we will put 5 and 5 water molecule will be produced. Now how many oxygen is present on the product side? 8 plus 5. 8 plus 5, 13. It means that we can write here 13 by 2 molecules of oxygen will be utilized. Now if we remove this fractional part of the equation, we can multiply whole equation by 2. Then equation will become 2C4H10 plus 13O2 and gives 8CO2 plus 10H2O. Now this is a balanced chemical equation of the complete combustion of butane. Similarly, whatever the compound is present, alkane, propane, butane, pentane, hexane, octane, whatever the case, definitely all of these compounds will be balanced just like this. On complete combustion, they will always produce carbon dioxide and water as the only product along with the heat. Due to the production of large amount of heat energy, all of these are used as fuel. This is a complete combustion products. But if incomplete combustion takes place, then what will happen? For example, if we have C4H10, if incomplete combustion takes place, it will react with oxygen, but as a result of incomplete combustion, carbon monoxide will be produced along with water. Now, depending upon the product, this equation can also be balanced by putting, for example, 4 carbon is here, 4 carbon is here. Now 10 hydrogen is here, 10 hydrogen is here. How many oxygen now? Oxygen are 9. It means that we can write here 9 by 2. 9 by 2. Now equation will become balanced. If we remove this fractional part from this equation, the equation will become on multiplication by 2 C4H10 plus 9O2. This will give 8 carbon monoxide plus 10 water molecule along with the production of heat energy. Now this equation is also balanced. Now on combustion, all alkanes, or rather hydrocarbons, they will produce carbon dioxide as a result of complete combustion and carbon monoxide as a result of incomplete combustion along with the production of water vapors. All these are the examples of combustion reaction. The second type of reaction is substitution reaction. Substitution reaction. That is called as a free radical substitution reaction. The most common example is reaction of methane with chlorine. 3 steps are involved in this process. Number 1, initiation step. In this step, chlorine molecule is provided radiant energy, and this molecule converts into 2 chlorine free radical. The production of free radical from a molecule is called initiation step. Second is propagation step. If one free radical is consumed and second free radical is produced, then all those steps are called as propagation steps. How propagation steps work? For example, this is methane molecule, and in methane molecule all bonds are pair of shared electrons. These are, if a free radical attack on this molecule, it will definitely attack on one of the hydrogen atom, producing HCl, and what will be left? 1 electron of hydrogen is utilized in formation of 1 covalent bond with HCl, and 1 electron of carbon remain unpaired on this carbon. So we can write at CH3CH. It means that chlorine free radical is used up and methyl free radical is generated. Now, in the next step, what we get? In the next step, this methyl free radical attack on chlorine molecule, which contain 1 pair of electrons. When methyl will attack on one of the chlorine, bond will break from here. What will be the product? Product will be CH3Cl plus Cl. Methyl free radical is used up and chlorine free radical is produced. Now, once again, this chlorine free radical attack on this chloromethane and will be converted into HCl, and plus what will be the now free radical will be CH2Cl. This will be the free radical. Now, this free radical once again attack on chlorine molecule, taking up 1 chlorine and producing CH2Cl2 plus Cl free radical. In the next step, this dichloromethane will be attacked by free radical. Then 1 more hydrogen will be picked up by chlorine free radical, producing another free radical CHCl2, this free radical. In the next step, again, this free radical will attack on chlorine molecule, will obtain one chlorine more, making compound CHCl3 chloroform and producing a free radical once again. Now, this free radical once again attack on the same molecule CHCl3 plus Cl not. Definitely attack on this molecule. Now, it will produce HCl plus CCl3 free radical. Now, this free radical will attack on chlorine molecule, obtaining one more chlorine, making CCl4 plus one chlorine free radical. In this manner, all the 4 hydrogen in the methane molecule is replaced in stepwise reaction. Then the last step is called as termination. Termination reaction, termination step, sorry. What is the termination step? Whenever free radical comes in front of free radical, both of formulate a covalent bond without producing any free radical, that step is called as termination reaction. Termination step. Now, in this case, there are 3 chances. Number 1, chlorine radical may come in front of chlorine free radical, make a chlorine molecule. Second chance is chlorine free radical may come in front of methyl free radical, making chloromethane. And the third chance is methyl radical comes in front of methyl radical, producing ethane, CH3. Now, all those steps in which free radical combine together without producing any further free radical, those are called as termination steps. In this manner, all of these reactions are the example of free radical substitution reactions, which are the basic fundamental property of a saturated hydrocarbons. I have explained all the steps involved in the process. Hope you have understood of the concept about the free radical substitution reaction and the introduction of hydrocarbons. Please comment, like, share and subscribe my YouTube channel for the upcoming video lectures. Thank you all.